Factorizing quadratics. Let's say we have the equation x squared plus 3x plus 2. So now what we look at is what number is in front of the x squared. So here it's effectively 1, and then we look at the number at the end, so there's 2. So on the side what we do is we work out what 1 times 2 is. So we multiply these two numbers together and that gives us 2. Then we write all the factors of 2. So which two numbers multiply to give you 2? So here we got 1 and 2. And then we look at which pair add up to the number in front of x, so 3. So here 1 plus 2 is equal to 3, which is the number we were looking for. So now we rewrite this equation out. So you write x squared plus, now this 3 can be split by 1 and 2, so we split it. So we write x plus 2x plus 2. Now factorize the first two separately and the last two separately. So x squared plus x we can factorize as follows. So x bracket x plus 1. Now by taking x out as a factor, we effectively divided by x on both terms. So x squared divided by x gives you the x, and x divided by x gives you the 1. Now 2 is common in both, so we can take 2 out as a factor, and effectively we're dividing by 2 in both. So here 2x divided by 2 is just x, and 2 divided by 2 is 1. Now you'll notice that x plus 1 appears in both, so we take this out as a factor. Now at this stage, if your brackets are not the same, there's something that's gone wrong early on. And that leaves us with, so effectively we're going to divide by x plus 1 in both of these. So x plus 1 would cancel, we're left with x, and this x plus 1 would cancel, and we're left with 2. So now we have factorized x squared plus 3x plus 2 into x plus 1 bracket, x plus 2 bracket. Let's look at another example. X squared plus 13x plus 42. So again, we look at the number in front of the x squared, which is 1, and we look at the last number, which is 42. So now 1 times 42 is 42, and we look at the pairs of 42. So we have some options. So here we have 2 and 21, 6 and 7. Okay, so now we've found a pair here, so we can stop here, that adds up to 13, which is the number in the middle. So now we can rewrite this out again as x squared plus 6x plus 7x plus 42. We factorize the first two, and we factorize the last two. So for x squared plus 6x, x is common in both, so we can take x out as a factor. So we're left with x, so x squared divided by x is x, plus 6x divided by x is 6. Then we look at the red part, so here we have 7 that is common in both, so plus 7 bracket, 7x divided by 7 is x, and 42 divided by 7 is 6, so we have plus 6. So now these two brackets are the same, so we can take those out as a factor, x plus 6, and we're left with x plus 7, from these points here. Now let's look at another example. Y squared minus 4y minus 60. So we have a 1 in front of the y squared, and we're interested in minus 60. The sign is important, so we're going to treat this as minus 60 here. So 1 times minus 60, which is minus 60. So we look at the pairs here. Now the two numbers that we write must multiply to give you minus 60. So we can write 10 minus 6 minus 10, 6. Now we can stop here because the sum of these is equal to minus 4, which is what we were looking for. So we can rewrite this out as y squared minus 10y plus 6y minus 60. Now, the question you may have is whether it makes a difference to write this out as y squared plus 6y minus 10y minus 60, as this still adds up to the minus 4. It actually doesn't matter, so you can interchange here. You can write it in any order, because if I had written this as 6 and minus 10, it'll still be true. 6 times minus 10 is minus 60, and the sum is equal to the minus 4 that we're looking for. So continuing from here, we will factorize the first two and the last two. So y squared minus 10y, y is common in both. So we take y as a factor. Y squared divided by y is y, and minus 10y divided by y is minus 10. Then we do the bit in red. So 6 is common in both 6y and minus 60. So we can take that out as a factor. So we're left with y minus 10. Now here, the two brackets are the same, so we can take that out as a factor. So y minus 10. So we're left with y plus 6. So it's important to keep track of the signs. So if it's add up to a minus, and if you're trying to sum up to a minus, it must add up to a minus as well. Let's look at another example. X squared minus 7x minus 18. So the number in front of x squared this time is 1, and the number at the end is a minus 18. So we have 1 times minus 18, which is minus 18, and then we list the factors. So the factor pairs of minus 18 is minus 9, 2, 2, and minus 9. In fact, we can stop early on, so we can stop here because we found the pair that adds up to minus 7. So we can rewrite this out as x squared minus 9x plus 2x minus 18. And we factorize the first two, factorize the last two. So x squared minus 9x, so we take x out as a factor, so we're left with x minus 9, and 2x minus 18, so we can take 2 out as a factor, so we're left with x minus 9, and these are the same, so we can take this out as a factor, so x minus 9, and we're left with x plus 2. Now in this example and the previous examples, you'll notice that this minus 9 is the same as this one here, and this plus 2 is the same here. So why did we do it in such a long way to get to the answer when effectively at this stage, when we wrote the factor pairs, we could write x minus 9 and x plus 2, and that would be our final answer. So the reason for showing this method is because you will need this method when the number in front of the x squared is more than 1. So for a shortcut, yes, the pairs can be used directly to write down factorize to write down your answer, but when the number in front of x squared is more than 1, you will need this method that we have just gone through. So let's look at an example where the number in front of x squared is more than 1. 2x squared plus 6x plus 4. So the number in front of x squared is 2, and the last number is plus 4. So we're going to look at 2 times 4, 8, and then we write down is factor pairs. So we got 1 and 8. Now the sum of those two is 9, which is not equal to 6. Let's look at another one. So 2 and 4. So now here the sum does equal 6. So we can stop there. So we can rewrite this out as 2x squared plus 2x plus 4x plus 4. So in the same approach, the first two will be factorized and the last two will be factorized. So 2x squared plus 2x, in this case we have 2 and x that is common in both. So we can divide the first one by 2x and the second term by 2x, and you're left with x plus 1. And in the red section we have 4 that's common in both. So we're left with 4x plus 1. So now the x plus 1 is common in both, so we can take that out as a factor, and we're left with 2x plus 4. So that's our quadratic equation factorized. Notice that now we don't have a shortcut where we can go from the 2, 4 to the final answer. Hence the reason for showing that method. That one method works on all cases, even if you forget the shortcut. Let's look at another example. 4x squared plus 13x minus 35. So here we need to multiply the two numbers, the number in front of x squared and the final number. So here we have 4 times minus 35, which is equal to minus 140. We then write down the factor pairs. So here we can write 14 minus 10. So the sum here is 4, but we're looking for 13. So that doesn't work. 28 and minus 5. Again, does it add up to 13? 7 minus 20. So this adds up to minus 13. So we're getting close. Minus 7, 20. And this does add up to 13. So we can rewrite this out again using the last pair. 4x squared minus 7x plus 20x minus 35. And then we're going to factorize the first two and then the last two. So 4x squared minus 7x. So here the common factor is x. So we take that out as a factor. And then we're left with 4x minus 7. And in the red section, we have 20x minus 35. So the common factor here is 5. So we're left with 4x minus 7. Now these two brackets are the same, so we can take those out as a factor. So 4x minus 7 bracket x plus 5. So now we have factorized the quadratic equation. Let's look at another example. X squared minus 1. So here notice we don't have an x term. So effectively what this says is 0x in the middle. So our approach stays the same. We look at the number in front of the x squared and the last number, the constant, and we say 1 times minus 1, which is minus 1. We look at the factors. So here it's 1 and minus 1, and this adds up to our 0. So now, as we know our shortcut, we can go directly to the answer as x plus 1 and x minus 1. But if we didn't know our shortcut, the method we used before can still be used. So we can say x squared plus x minus 1. We factorize the first two, so we have x bracket x plus 1, and we factorize the last two, so we have minus 1, x plus 1. Now notice here, we could have said, oh, let's factorize by plus 1, and then we would end up with a minus 1 and a minus x. But our aim is for these two brackets to be the same, so hence why we need to take out minus 1 instead of plus 1. So now these are the same, so we can take that out as a factor. x plus 1, and x minus 1. Let's look at a similar example. Let's say our question is 6x squared minus 6. So here what we would do first is take 6 out as a factor. So we have 6x squared minus 1. And then we would factorize this in the same way we did this part here. So this then becomes 6 bracket x plus 1, x minus 1. And that's our final answer.
You can download the application on Google Play or App Store, and you can visit our website mathslegends.co.uk.